Well, hi, and thanks so much for joining me here in my shop. I'm just about to start on this radio. Today is February 2020. Wow. Okay. So, I think I might call this Dirty Ugly Radio. Dirty Ugly Painted Radio. Ugly Painted Radio. Maybe that's what we'll call this one. So, yeah, ugly, alright. Perhaps it was in bad shape, and whoever painted it brought it up at that time. We don't know. Or this was a beautiful wood cabinet radio, and somebody painted it because there was a period where a wood cabinet was, well, it was a sign of you just weren't with the times, kind of. So maybe if you could make the wood disappear, you have a radio of the times. Yeah, right. Knobs have been painted. That's bad. That's always what they end up looking like. Might as well pull it off. Let's see. So there's no name on the front of this radio. Maybe it's painted over. Maybe it was, I don't know. Viking. So Viking is a brand name of a retail store, a big retail operation here in Canada, which is gone now. It's called the Eaton's Company. Eaton's was a store everybody knew about, and certainly when I was a kid, the Eaton's department stores were very, very busy and popular. But times change, Eaton's disappeared. So their electronics brand was called Viking. Now, who exactly made this in reality? Dominion Electrohome Industries Limited is who actually made this under the Viking brand for sale in the stores. So warning, disconnect cord before. Okay. There's a number up here. 7931. That looks like an auction number or something like that, I would guess. I'd love to just plug it in the wall and see what happens, but let's not. Let's take the back off and have a look at what's going on in here. Then we'll plug it in and see what happens. So this is one of about 15 radios I bought all at once from one individual who offered me a very good price on them. And so he told me all the radios were working. And again, that word working, that means different things to different people. Has there ever been a radio I brought in my shop that has in fact required absolutely nothing done to it because it's, quote, working? I don't know if that's ever happened, actually. I mean, a good working radio shouldn't really make it to me, should it? That's kind of not the idea. Okay, this obviously this must be the antenna terminal connection here. Oh, guess what? So you see that? And you see that? Those two rivets? And see the way this is flopping on the top, not flopping at the bottom? All indications are this is fixed onto the back of the radio through these rivets. So don't pull it out. Almost certainly the radio is held in place by some bottom bolts. Let's see. Oh, look at that. Oh, it's not quite as... I got excited. I thought it was a schematic. There's that number again. 7931. Series... looks like EU1 4516. Model... oh, son of a gun. The model number is here. It's gone. EU1 4516. This is a series. I'm not sure what they mean by that. Series. Bad guessing here. This blue one. I haven't got many more of these left. Must be the green one. What? Is it in fact? Well, that's odd. What have I got left here? I got almost 9 of these tools left. Here's one. What an odd size thing this is. Who's left here? I've gone through every one of my... Well. Asbestos powder right there. Asbestos fiber, rather, not powder. Just make sure there isn't any person installing or operating this unit without a license going to be in trouble with the king. Does it say the king? Just talks about the minister of the Canadian government. You have to forfeit your radio to the minister. You personally come and get it. So I think that tells me this is a pre-end of the war radio, or maybe right around then. I'm not sure what the date is on this. Here it comes. Ta 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 ta. It's all there. There's the antenna on the back. Okie dokie. And look at this interesting thing they've done. Let me just get rid of the cabinet here. There's no asbestos in the cabinet, so it's been removed. That's what's happened. Nothing spectacular in there. Good and solid. Yeah, rock solid cabinet. Oh, the asbestos came with the radio. Oh, okay. The sheet is stuck to the bottom of the radio here. So, So I'm going to take this out of my house and remove the sheet from it. And then I'll be back momentarily. Okay, let's look this guy over and start planning what should be done with it. Let's take a good look at it here. So it actually looks to be pretty good. It's quite clean, in fact. So I think somebody's been in here and cleaned this guy up at some point. Speaker's got a little hole right there. Interesting thing, I said there's something interesting here, is the manufacturers have put a scale on the top, so when the chassis is out of the radio you can still read a scale and do the alignment, provided the radio goes back in the correct position. Some radios can shift left and right a little bit, not this one though, because it fits snug because of this in the cabinet. And there's not much else to see on the top here. 1, 2, 3, 4, 5 tubes. Do you see a power transformer on here? No, we do not. The knobs that were protruding. So it's starting to give you an idea of just sort of the vintage of this radio. A later 5-tube radio, the knobs would not protrude. They'd be recessed into the cabinet, and what would protrude is the knob would have a big neck on it and stick out here to reach in. So if you pulled the knobs off, unless you stuck your finger in, I mean, they can't stop you from being crazy. You could never touch the chassis. But this one's not the case. The screws on the bottom were going into the chassis too. Now let's take a look at how they dealt with the antenna problem. So the antenna is a terminal on the back of the radio that obviously connects electrically into the radio. Yet at the same time it can provide, or not provide, but end up providing a shock point. depending upon how they handle this. Now, the normal way to prevent somebody from getting a shock here is to reduce it to the point where they don't know they're getting it. And you do that by sticking in a capacitor. Usually a small size capacitor. This is probably it right here. So that's a fairly large mica capacitor, a relatively small capacitance. So if by some chance you do draw power into your finger through here, it'll be so small you won't even know what happened. You know, people are going to hook up a wire on this, and then they're going to run out in their backyard, and they're going to trudge through the wet grass with their runners full of holes, or back in the day their whatever shoes full of holes, so they're actually grounded as they walk, holding on to this wire that's attached to this terminal. That's enough to kill people if things weren't done right. People get killed with their lawnmower extension cord with some regularity for exactly the same thing. Trudging through wet grass and holding on to that handle with both hands firmly. People die. I don't want to die. That's why I have a gas-powered lawnmower. Okay, let's look underneath here. Oh, son of a gun. There we are, first repair. Done. Repair complete. So, oh, somebody has been under here. Yes, they have. No, they haven't. Oh, we got to get the close-up camera on this guy. So, well, here's... Somebody did this. Somebody did this cord. And the old cord wire is right here. There's like a couple inches left, and it's dry and cracked and bare copper all over the place. Which is, see, this is a good reason for not turning this radio on without first examining it. This is crappy. Well, why? So, you know, if somebody isn't going to replace this cord all the way up onto the back there, that suggests they don't have a soldering iron. That suggests they do not have a soldering iron. Let's see what happened here. They did not have electrical tape. This is medical tape they've used here. It's kind of interesting. See how that worked out. Not so bad. Did they solder this connection? And the answer is no. It's just twisted together copper wire repair. There you go. Man, I tell you. Still got the big old original filter capacitor. You see some heavy corrosion right here. That's very interesting. We'll take a closer look at that. In green there. I'm just taking the long shot right now. So we've got no capacitor replacement in here, anywhere that I can see. Doesn't look like anything's burned up. Let's see. Here comes my cat. Here he comes. I'll beat him to the door this time. Meow. Come on in. No, come on. Come on in. There's a bit of a pattern here, isn't there? Peanut? What do you want to do, Peanut? Show me what you want to do. Where do you want to go? Oh, he's preoccupied. Where do you want to go? Oh, he's going to come in. He's going to come in. Well, you're wondering where Shadow is, our other cat? Come on here. Oh, come on, big guy. Look up in the camera. He's a beautiful cat. Yeah, that's it. Just kind of looking up in the camera, sort of. Peanut is 9 years old. He's getting old. He's getting heavy, too. Okay, did that settle you down now? Are you reassured? It's burning up a storm here. Down you go. There you go. Okay. That's right. You're not forgotten about. Okay. Let's see if we can carry on. Yes, he seems to make a daily visit in my shop here. Now, where was I? I was talking about nobody's done anything in here except replace the power cord. And, okay, so we've got these 3 molded capacitors. They are bad actors for sure. seen this type around quite a bit. And then all these wax ones. What are the chances that this radio could operate in this condition? Chances are actually pretty good. What? How dumb and stupid is it to try? So if this cord is good, I'm going to reattach it. We'll just use the cord. I'll just do it properly. Yeah, that's right, Peanut. Let's go over with the close-up camera here. Take a good close look. How are we on the focus? Good. Are you back here? Oh boy, he's really giving me a look. Okay, starting in the bottom corner. Looking for burned out parts, things out of sorts, interesting stuff. There's the power wire that's all cracked to pieces. Anything else all cracked to pieces? I don't think so. Look how the paper sleeve has drifted on this radio, on this capacitor. It's drifted downwards. Yeah, look, it's loose as can be actually. Huh. Didn't really drift. What's that tell you? I don't know. It tells me they're shrinking a bit, maybe. There's a big resistor mounted on the side of the chassis. Looks to be in very good shape. Yeah, actually I'm not seeing signs of heavy use. Heavy use, you see blackening, like these tube sockets get blackened from heat. They get cooked. So this, I've discovered in a lot of these radios, they have a terminal strip somewhere in the middle of the radio, like this one. This terminal strip is kind of in the middle of the radio here. And often they make connections to it which are very advantageous for testing purposes. Not necessarily, but sometimes these are the key testing spots. The terminal strip has two brackets going down to the chassis. See, neither one is soldered, and neither one is used as a terminal point. Oh, now that is soldered. So that blob of solder is from pin number 1. Is that pin number 1? That's not pin number 1, is it? I guess the pin is right in the shadows here. I can't quite see it. No, it's on the other side. 1, 2, 3, 4. I switched tubes, didn't I? That's what I did. I switched tubes. Yeah, there it is. Pin number 1. Solidly to the chassis, and almost certainly, if we look at that tube, it's a metal tube. There it is, metal tube. Oh my gosh, Peanut. Okay, I can't ignore him any longer, or he's gonna get depressed. He's thinking, yeah, I gotta go deal. I gotta go play with my cat. Yeah, hang on, I'm coming. Okay, cat's all happy now. Let's carry on here. So, didn't really get anywhere, I don't think. It's cracked, right open. This one's cracked also, I think. Cracked down the seam. Cracked open, but the paper's still loose. Yeah, look at that. Wow. We'll be able to open this one right up and take a look inside when we get around to replacing it. Pretty sure I'm going to replace them. Let's keep going up here. Oh yeah, that's right. We got past the big resistor. There's a bit of a high wattage resistor there. Not really high. Another terminal strip. What I'm looking for is the point at which the B minus is tied to the chassis, probably through a capacitor. See the grommets under the screws there? So that's probably holding the capacitor here. Yep, for sure. So the capacitor frame is isolated away from the chassis. And the reason is it's the chassis that's actually isolated away from the radio, except for some kind of capacitor that'll be in here somewhere. So, you know, the problem with the big capacitor is how do you fix it to the radio so it doesn't fall off? You have to screw it down. What do you screw it to the chassis? It'll be shorted to the chassis. Hey, take it all back. Look at that. Take it all back. Everything I just said is removed. So, yeah, it's connected right to the chassis. So maybe we've got a case here of the front end of the radio runs with the chassis, but the back end doesn't. I don't know. Here's another interesting thing. So, maybe it's not so interesting. Yeah, maybe I was going to make a point I can't make. So here's a coil. That wire lead look broken? Son of a gun, it really looks like it's broken off, doesn't it? Wow, what are the chances I would spot something like that? Let's go and get a poker here and we'll poke it. Okay, steady up my hand. Just trying to get the camera focused good. Oh yeah, it's definitely off. Look at that. Man, am I lucky that I found that. Now there's another wire heading downwards. Whoop, whoop. Oh yeah, so there's a wire heading down to that ground terminal, so I will be able to say what I was going to say. And I don't know if it's true. That wire is actually soldered on the outside of the chassis, indirectly. Now, I mean, this might be the way it is because this is easy to do. You can even see the chassis looks like it got scraped before they did the soldering. I'm sure that's a factory thing. I'm not trying to suggest otherwise. What a lucky break that I spotted this break. Wow. So this radio was sold to me in working condition. Well, you know what? We don't know exactly what this wire is. Maybe the radio was still limping along. Kind of doubt it. Doesn't make turning it on sound like a good idea at this point. Wow. So that wire would get broken because something struck it, something yanked it, something tugged on it. That's really like it was right in the wax. How exactly that happened, I don't know. That's interesting. That's quite curious. And how it is I managed to spot it. Wow. So I'm looking at the wire insulation where the wires are going through holes and seeing if there's any problem with shorts or anything like that. I don't see anything. So the one thing I did not look at is look at the top of this capacitor. Look at this whole capacitor here. Yikes. It looks particularly bad. I mean, you compare that to that. I don't know why it would look so different, but you know, in terms of the wax being the hermetic seal, not much happening here. Oh, you know what? So there's a big capacitor here and a resistor tied right around it, and almost certainly this end is soldered to the chassis. So this is the chassis drain, if you like, to drain any charge or voltage signal, whatever you want to call it, that's building up in the chassis. Drain it right back to the negative bus. That would be this terminal up here. Quite a blob of solder down there. So that's how it's done. So this would be the one connection to the chassis. The idea here is the B minus terminal is there's a chance that terminal is hooked up. Well, it's hooked up to one of these two prongs. Well, this is done poorly too. We have to fix this up. Yeah, this is terrible. By the way, this is not what you want to do. You know what's going to happen here? Obviously, those strands are going to make it across and short. But worse yet, something worse yet can happen. Let's see if I can make it happen. Well, these loose strands, it's going to come walking outside of the plug. Here comes one. Maybe this one. Maybe I can't quite get it to go out right now. Yeah, there, see? And so next time you grab the plug, you're going to touch that. I mean, there isn't even a cover on this, but that's less important than having this wire. Oh man, this is bad. Let that be a lesson to you, whoever you are. The cord itself is in good shape though. Okay, fire up this radio, yes or no? Well, sure, we should try it. Sure, we should. This filter capacitor is almost certainly a piece of junk. So almost certainly this radio there's no hope of working. But I was told it worked. So I'd like to find out. Well, I can do this in a way that doesn't risk anything, so why not? First thing I gotta do is I gotta repair the power cord down here and get that sorted out. And as I said before, I think the wire's in pretty good shape actually. So I'm just gonna get rid of this piece of junk they left in the radio. And then we're going to try plugging this guy in. You know what? This might not have even been the original cord. How easy it is to get off here. You know, that may not have even been the original. So what's the purpose of solder anyway? Well, obviously solder does a number of things. It's an electrical connection. Solder's not great for passing electricity, but it's not terrible. Another one is it mechanically and physically holds everything in place, of course, it's like glue. The last one is it blocks the wire strands from being exposed to the atmosphere so they won't oxidize underneath the Now, which wire should go where? It doesn't matter. This is not a polarized plug, and this radio is built to be plugged in this way or that way. Just noticing how bad this capacitor is right on the top here. The cardboard tubes open a little bit. The wire here. Again, working with stranded wire. Left a lot of solder on that terminal. Let me get the solder off it. The big blob of solder, and you wrap the new wire around the solder, you're nowhere near the terminal. And when you melt the solder, the wire that was fairly tight is actually completely loose. Now there's another piece of wire on here. So I think, I don't think I can get it though. I think that's probably good. That wire is probably the original wire. And the reason the cords wear out is because they're flexible. And to achieve the flexible plastic, longevity of it is sacrificed. It's not a long-lasting plastic. I don't want this to be messy here. There's something behind here I can't see. What exactly is going on there? It's just a lot of excess solder. Okay, let's try again. Strands everywhere. All. Now you can tin these ahead of time, and there's advantages to doing that, but the disadvantage is sometimes it becomes just too big a wire to kind of manipulate easily in here. That's a lot better. Time to solidify. Good. That's good. That's a nice job. Now the other one down under this capacitor here. So today is Groundhog Day, and Poxitani Phil has done his thing, but there's a Canadian one called Wiarton Willie. Wiarton Willie. Wiarton's not far from here, and they do the same thing every year. They bring out an animal. They call him Willie. They do it in Wiarton, and bingo. It predicts the future. What a joke, anyway. Okay, there we go. Why'd I even bring that up? I don't know. Small talk, you know. So this is terrible. This didn't work at all. This is bad news. It's really bad on so many accounts here. As in, it didn't even solder. Let's try again. I think the reason that didn't work is I can't see so clearly in there. Looks like I heated up the terminal, but didn't heat up the wire very much. That's probably part of it. Better, but still got way too much play in it. Get it soldered around the backside. Hopefully, oh my god, my phone's in here. Ah! Okay, so am I even hearing some funny sounds on this video from my telephone? Which I try to remember never to bring in here. Yeah, this didn't work again. So I got it soldered this time, but there's just so much free copper there. That's just no good. Not on a power cord. No. The power cord's going to get tugged on. It's not strain relief particularly well. That's better there. Okay, I think I can probably solder it underneath now. Lots of solder everywhere. Get on. That's good. That one's good. This cord goes like this. This guy sits like that. No wave's going anywhere he shouldn't. Nothing shorted out. Let's try something a little funny here. Never tried this before. We'll take the plug here. That's a long cord. I'm going to hook it up to the ohm meter. Right onto the chassis. We're on the 20K scale. Let's go up here. So this resistor, we're trying to measure this resistor here actually. So that's a 27, looks like 270. Now you see 270? Now if I flip to the other terminal, you should see basically, I think open circuit or extremely high resistance. Doesn't mean anything. Very good. Now we're going to go back to this terminal. And I'm going to turn the on-off switch here. Turn on. Turn it off. Yeah, not making any difference. And likewise on the other terminal. Why am I doing this? Just to see what happens. I'm suspicious. And nothing happens. Nothing interesting happens. Okay, that was an interesting little test. What are you trying to do there, Jim? I don't know. Verify that there wasn't a solid short between either of these prongs and the chassis. That's what I was doing. And there isn't, this resistor appears, so this capacitor can't be shorted, so this chassis won't go totally live. Now, if this is one of the first videos of mine that you're watching, in my shop here, I use an isolation transformer which feeds this outlet. So this outlet, as much as it looks like a regular 3-prong sort of outlet, no it's not. It's just going to a transformer. It has 120 volts on it. And see that ground terminal? That ground terminal goes nowhere. This is plugged into a 2-wire extension cord going to the transformer. There is no neutral, like power company neutral, ground wire, green wire, whatever you want to call it, associated with this outlet. So what that means is I can plug this radio in and I can take one finger and touch any one thing while my other hand is grounded on a piece of equipment. Because there's no connection in the radio, back to the power system and the ground. That's the theory. I would never test it except by accident. So the reason I'm bringing this up is because this is a 5-tube radio with no power transformer. Almost certainly the heaters are in series. I mean, not almost certainly. Certainly the heaters are in series. It has a we gotta fix this plug. It has a non-polarized plug. Different radios of this sort are done differently. That screw I just undid, that was loose. It wasn't even snug. Okay, let's pull this out. Push it through. Push it through. There is a way to do this. Look at how long that is. Crazy fool. Crazy man. Crazy man. There is a right way of doing these, which I will now demonstrate. Raise the screw higher here. So again, basic rule: stranded wire, problems. Strands come free, wander around. This is crazy long. So I'm just tightening up the twist on it. Come up through the center. Go around a long way behind the plug, like that. Under the screw. Now this is quite important too. If you're not familiar with doing this kind of stuff, there's a right way and a wrong way to put a wire under a screw. If you put it the wrong way, as you tighten the screw down, the screw will drive the wire out from under it. And you'll just find yourself every time you go to tighten it, the wire jumps out. If you do it the right way, as you tighten it down, the wire will pull under the screw. Let's try this one. This is the right way now. If you just think about it, or are observant, you'll get it right. So the objective here is to get this done without any strands that can come and cause problems. So I'm going to cut off some excess wire here. This is my plan. Oh! I wasn't expecting that. I just shot a shower of tiny copper particles all over my tube tester, and oh my gosh, doing a little vacuuming later today. Still a little bit sticking up there. Now there's supposed to be a cardboard cap that goes over top of these, of course. So here we can do this one. Around a long way. Raise the screw again. There's a broken strand falling around in there. Get it out. Screw in the right direction. Access. Only this time I'm going to shoot it. See, now that's what I was expecting. Oh my gosh, this has all been done off camera. I hope not. No, I think I got it okay. Tighten these down really good. There we go. That looks a little better. Nothing hanging around the edges. Hey, we're very close to operating this radio now. Okay, one or two more observations. What? This is the tuning, obviously. Why does that feel terrible? Get some lubrication. I think it's binding up in here. Volume and on off. Yep. Bare knobs. But again, this is plugged into an isolation transformer, so I'm not concerned about grabbing this. We'll verify all this stuff too. Okay, we're plugging in but no power. making sure the switch is turned off, applying power and expecting nothing to happen. Now again, if you're new to my videos, I use a very simple way to prevent a disaster. The disaster being a really bad short circuit that's going to draw a huge amount of power when I turn this on. If there's a huge short circuit in there, let's say I just put that power cord on there and like an idiot I soldered the ends together, maybe I did. You need some way to be prepared for that event, especially if you're me actually. So I use a dim bulb system. These two light bulbs here, the power, I can throw a switch up here on my switch panel, which you'll hear me clicking all the time. This is the arm it, and then this will apply, if I flip it down, will apply power to the outlet that the radio is plugged in. And when it does, if I flip it down, the power is going through these light bulbs to get there. So it's like a resistor, if you like. And the cool thing is, if the radio is drawing too much power, these lights come on. And if there's a dead short here, they come on just like you plug them in the wall. But normally they come on very dull, because they're just restricting some of the power coming to the radio. So this initial turn on, it's really important to have something there, unless you want to stake your future on your circuit breaker in your fuse box. You just, to go a little further, I also have a fuse in line here. I put a fuse in the line going to the outlet, just in case. Just in case. That's a couple amp fuse, I think. I can't remember now. Now this thing will also, because I have this fancy power analyzer on the plug here, I get to read the voltage right here, and I can also look at the power being drawn by the radio and other things. So this is quite handy. I also notice this ground wire just came off, so let me put it back on. So this is what I'm doing now. I have a bit of a oh no, that doesn't have to go there, it's over here. I won't go into it. It's just another way in which I try to keep myself safe in the shop here with all this stuff. I won't go into that because it's not important. We're close to turning this guy on. We'll apply power, nothing should happen. Good. Whoop. No lights came on. Now we read the line voltage. On the other side of my isolation transformer, 124 volts. That's normal. I'm going to flip the radio on. I'm going to use the radio's own switch here. When I flip it on, this light should come on, fairly bright, and then go dull, and then come back up. If on the way back up, the sound should start coming out of the radio. And that's what should happen. It can happen fast. It can happen so you can't even see it. Or the light's going to come on bright, and I'm not going to do it this way. I'm going to turn the power off on my panel up here. Turn the power on down here. I'll operate it from up here. And the most likely thing, a big blasting hum is going to come out of this radio, and that's going to be the end of it. It's going to be on for like 2 seconds and then off. Here we go. Okay, so we got something not happening here. 112, so it's drawing power. Or it'd be 124. The light did not come on, so it's not drawing much. Tube's lighting up. If one tube lights up, they're all lighting up. 118. Volume up. Here it comes. Oh, not so bad. Okay. Look at that. That's with that wire off. Okay, well, is it really receiving anything? We don't know. So, you know, somebody hears this, radio working. Can't you hear the hum? It's working. We'll kill it. On-off switch works properly. So that little test was enough. The radio generally working, that's fantastic. That's what you want. Any sound coming out is better than nothing. So you're off to a fairly good starting point with the radio. If the radio doesn't work at all, and then you gotta get it to work a little bit, I think, before you really get into it. That's my own my own style. So the first thing to get rid of with this radio is the hum, and do that big power supply capacitor in here. Just separate this. That'll be the first thing. And then it's almost, unquestionable that all these paper insulated capacitors got to go. So it's these molded ones and these ones. This is a guy, there's something in here. We never looked that closely. I really want to look at it. I think that's how we'll end the video. We'll take a close look at something in here. This guy first, test the radio, see what happened, and then selectively, based on the results, probably this guy next to make sure that that this is safe and secure here. Then probably a selection from the rest of the capacitors, probably starting with the audio capacitors, the capacitors that are in the audio circuit, then followed by the front end capacitors, and then that's kind of it for this guy. There's two resistors here. I didn't notice that. Two of them, same size, 70. Well, it has a number and a model number. They're identical. Well, they look like they're just in series. Okay, great. Let me get my other camera here. We'll take a close look at something. So right on the top of this big capacitor is a resistor with a lot of corrosion there. Now, I'm an ex-corrosion technician. The kind of corrosion I dealt with was underground corrosion on lead sheath power cables affected by a DC traction transit system in the city of Toronto. But in learning about that specific corrosion problem, I learned about all the general stuff. So, the green is definitely a salt of copper. Copper chloride, copper sulfide, sulfate, something, copper something. Why there? What is happening right at that point? It's not happening anywhere else in this radio. Well, this big honking capacitor is sitting there. I'm looking at the seal around the edge of that capacitor, and right in the area where that resistor is corroding, the seal appears to be bad. It doesn't really look like there's a contact there, is there? Yeah, maybe there is. So I think we can pretty easily conclude something came out of that capacitor that led to the corrosion of that little piece of wire there. Now, is this something important? No, probably not. It's just interesting to observe. Like, I don't think the copper wire has been eaten away to nothing there. Is there any other similar evidence of corrosivity? Now, I don't know what would be inside these capacitors that would be particularly corrosive. This is probably just a sealed up bottom here. We're not going to see anything. Yeah, I don't know what would be in them. What corrodes copper? I'm not sure. Copper is fairly corrosion resistant. Lucky people. Lucky humans. Aren't we lucky? Man, we live in a world with all the right stuff. Or is it just because we figured out how to use everything that's here? In our part of the universe. So I don't think this really requires any attention beyond just looking at it. So I think that's it for now. Next video, we'll just start working our way through these capacitors and see what we end up with. Good. Well, thanks a lot for watching this morning, and we'll catch you on the next video.